Today I've received this question, and this question is Math Olympiad, one of the Math Olympiad questions in Germany in 2015. So please pause this video and try to do this. Okay, it seems you have done this, so for those you haven't done, just look at the solutions. So as you can see, we have these two equations. We have x cubed and then, well, y cubed at the same time. What can we do with this? A bit of manipulation work. So as you can see, I noticed that the x squared y and the xy squared here, they have a common factor of xy. I'm gonna use this xy to solve this problem. So let's try to take the first equation, this one, and this is the second one. Let's take the first one. From the first one, we have x cubed plus 9 x squared y equals to 10. And then we have then x cubed plus 9x times xy equals to 10. And I used this xy to solve and to substitute this entire thing in terms of x. Okay, and I will have as a result x cubed minus 10 over 9x. So you apply the same concept at the second equation. You will have y cubed plus y times xy equals to 2, and then xy equals to nothing but y cubed minus 2 over y. And then we try to equate these two, and we get x cubed minus 10 over 9x equals to y cubed minus 2 over y. And the next step, which is very important, I'm gonna try my best. Okay, I just eliminate the fraction by having the cross multiply. I will have this, and I will have this too, which is, this one is supposed to be 18 something, 18x. As you can see, it's kind of symmetrical, but I can try to make a further manipulation by isolating those with cubes on the right hand side and those with only a linear, well, with only power 1 like xy on the left hand side. So I will have 18x minus 10y equals to 9xy cubed and then minus x cubed y. And then I can factor out again the xy on the right hand side, and then I will have left, this one is y cubed, and then this one will be, well, x cubed. And as you can see, I have these xy. Should I actually substitute back? No, there's no need. It will be very troublesome. So why not I just try to move this thing down here and make a fraction here. So I will have a fraction on the left hand side, and then on the right hand side will be the expression inside the bracket, and then I will have at the end these things. So as you can see, I can also factorize this one out by having the, the difference of squares identity. You will have the 3y minus x and then times 3y plus x. And then, as you can see, this is a mathematical competition. So it's only valid for those real numbers to exist in the solutions of x and y. So we need to think about y and x, what numbers they can be. So we think about that they are one of the factors of the numerator, okay, which are 18 and 10. So for y, we have, it can be any factor, one of the factors of 18. So we have to list out the factors of 18. Excuse me. They are 1, and then 2, 3, 6, and then 9, and 18. And then we try for fx. Okay, this is not the function, but the factor. We will have 1, 2, and then we try 5, and then 10. So it's actually really time intensive to try all of these factors. So we can just try the first few factors that we can have, which are actually just try to use 1, 2, 3 in this case, and then 1, 2, 5 in this case. Or you can just try basically 1, 2. But in the end, if you have actually noticed that you can actually just use the 1 instead, because well, you could have actually noticed from this equation here, if you combine this one together with this partial fraction here, you can actually see the logic somehow that if you try to rewrite this expression back, you will have you'll be given the hint that if you have the minus sign here, you have to get the same difference on the left hand side and also the right hand side. However, now it's very easy to actually have the difference of 8. How? As you can see, there's an 18 and there's a 10. If you 18 minus 10, you will get 8. And if 9 minus 1 here, you also will get 8. So that's why x and y must be equal to 1, because of having the same difference, which is 8. So if you try the larger numbers like 2, 3, 6, and 2, 5, you will have to consider the fact that maybe this number here will have positive negative number, while this always remain positive, because 9y squared is always larger than x squared, no matter which one you are, which number of y you are given in this case. Yes, you might have thought that, well, it's very important to notice that it's not y squared, it's 9y squared, so it's very big. So no matter which number, which factor of y you have actually used, 9y squared must be always greater than x squared. And however, 18 over y minus 10 over x can be either positive or negative. So we might not know which one is which pairs. Okay, it's very so we can actually have calculated how many pairs we could have obtained. We have 4, and then we have 6 here, so we must have 24 pairs in total by using the multiplication principle, 4 times 6. So it's way too much. We just need actually just 2 out of 24 is just enough for solving equation in this case, because it's a mathematical competition. We don't have such enormous time to get rid of 24. We can just actually selectively choose 2 out of 24. This is enough. So in conclusion, x equals to y equals to 1. Okay, so I can use x equals to y equals to 1 for this difference of square here. So I rewrite back the equation. I will have 18 over y minus 10 over x, and then it equals to, in this case, 3y minus x, and then 3y plus x. So we know that we are solving for x and y. So x and y can have more than just how many maximum values we can have, because looking back at the equation, we have the highest degree of 3. So that means we must have 3 solutions. We must have 3 pairs of x and y. And hence, we must get 2 more solutions. So 2 more real solutions, remember. We must not have imaginary solutions. Because this is mathematical competition, usually we do not have time to actually think about the complex numbers. So y equals to x equals to 1, we can try to get the value inside this each single bracket. We will have, in this case, 3y minus x. Well, if x equals to y equals to 1, you will have 2. On the other side, you will have here equals to 4. So 3y minus x equals to 2. If you treat x and y as the other constants, as the other pairs of the solution of x, y, you can also have 2. And this thing goes to 3y plus x equals to 4. So we must try one of them. So which linear equation we label them as linear equation A or linear equation B. So which out of the 2 linear equations, which one can be used to obtain the real pairs of x and y? We need to find them. So how? So since this is a linear equation, we can just substitute x in terms of y or y in terms of x. To me, we can just substitute x in terms of y. So we try to use x here equals to, in this case, 3y minus 2. We can just try the first one, which is the A. So x equals to 3y minus 2. Substitute in one of the equations, 1 or maybe 2. In this case, I would suggest you to substitute in 1. X cubed plus this one, the entire thing. So recall back, x cubed plus 9 x squared y equals to 12, correct? 10, sorry. Okay, now we have x squared as 3y minus 2. So x cubed equals to 3y minus 2 cube. And then here, we could have actually obtained, well, in this case, my apology, I should have said that I should have substituted the y in terms of x. It's not x in terms of y, because it's very tedious. It will be very tedious if you, well, expand this expression. So how about we consider this one? This one, which is much better. So how can I get 3y here? As you can see, 9y, you can factorize the y becoming 3 and then times 3. So I allocate 3 for the x squared here and then 3 for the y here, which is, yeah, it's also the same if you try to multiply them back. You will have a 3y indirectly, right? So x cubed plus 3x squared and then times the 3y, which is x plus 2, and then you will get 10. Okay, and then you will have here 4x cubed and then plus 6x squared and then minus 10 equals to 0. So in mathematical competition, we are not allowed to use calculator to solve cubic equations. But we have actually identified that one of the solutions of x is 1. So we must have the polynomial, okay, which is this one, x minus 1, which can divide this entire polynomial expression. So we try to do the polynomial division, the long division, and we will have this entire thing inside the division sign, and then you will have a 4x squared, and then you will have this one, and then minus, well, 4x squared. Then here you will have 10x squared and then plus 10. Okay, as you can see, plus 10x, you have 10x squared, and then here you will have minus 10x. So it's not enough. You need some more further. This is minus, remember. And then you must have also minus 10 here. So plus 10. And you will have 10x minus 10. So it's okay. We have done this right now. So yeah, as you can see, we have obtained this so-called this polynomial expression. And then what you have obtained in this case is just the quadratic equation, which turns out to be 4x squared plus 10x plus 10, okay, equals to 0. Because if you try to consider back that if you factorize out the x minus 1, you have left that quadratic entire thing. The product of them must be 0. And hence, this entire quadratic thingy must be also equal to 0. And we try to solve for x like using the quadratic formula if you have memorized them. So you will have, yeah, it's not this one. Wait, can I check somehow? So it's somehow this one. This is 8. As you can see, we have 100 minus 160, which is something we do not want because we will have a complex number. So in this case, we must eliminate, in conclusion, we must eliminate this linear equation A as our choice. Okay, it's wrong. I have to use a red pen. This one. So we have no other alternatives, so we must use the linear equation B in this case. So we use back the same thing, which is this one. Okay, we try to manipulate them a bit. So again, we use a 3y equals to 4 minus x according to equation B. And you will have, okay, using the same manipulation technique again. As a result, you will have x cubed and then plus 3x squared, and then the 3y, which is a 4 minus x, equals to 10. And then you will have the entire thing, which is minus 2x cubed, and then here will be plus 12x squared, and then you will have here minus 10 equals to 0. So far you have done it correctly. And right now, I have to, this is correct. Yeah, so I have to do the polynomial division. So this time, so I transfer x minus 1 here, and then here will be your minus 2x cubed, and then plus, and then minus 10. So we try to deal with negative 2x squared first. So you will have this, and then you will have plus, in this case, and then you will have a 10x squared. So 10x squared minus 10, but I will leave them like that because that we have done that thing in fact a bit. And then the 10x, you will have a 10x squared, and then the minus entire thing, you will have a minus 10x, okay, and then you will have here nothing because for in terms of x you have 0x, and then 0 minus negative 10x, you will have 10x minus 10. Then you will have finally the 10 here, which is a 10x minus a 10. And then you will have your quadratic equation. Okay, using the same concept, you will have this one equals to 0. And then you will try to somehow get using this. Well, we try to further simplify this equation. You will have this equation here. And then you will have, well, I just want to check whether or not I'm able to get. Yes, I have, finally. So I can use a quadratic formula again. And then, yep, and then you will have this. This is 2. And then this is your x, 1, 2. And then you will have your 5 plus minus. And then this will be your 45. And then over 2. And then we can take it out, the 4. You will have, in this case, no, you will have a 9 and then 5. So 5 plus minus square root 9 times square root 5. And then times 2, you will have 5 plus minus 3 square root 5 over 2. Okay, I purposely done this because I have seen a bit like a golden ratio. In fact, the answer is it involves a bit of golden ratio. So this is actually the solution for x. Okay, so in conclusion, we have 3 solutions of x. Finally, we have 3 real solutions of x. So x1 just now we have obtained is 1, and then x2 and 3, they are 5 plus minus 3 times square root 5 over 2. So I will use back that linear equation, the equation B, which is this one, excuse me, to obtain y. So in this case, y equals to nothing but 4x over 3. And then you can use the entire expression, like, okay, try to manipulate them with an x. And then 3. And then what you will get is, well, in this case, you just try to multiply with 2. You will get 8. And then you have 6 here. And then you will have 3 plus minus, well, this is 5 actually. And then you have 6 here. And then you will have 1 plus minus 5, 2, which is the golden ratio and also the inverse golden ratio. Not the inverse, the second solution of a golden ratio. Okay, this is the prime and this is the second solution of golden ratio. So in conclusion, if for your x2 and 3, if your x2 equals to 5 plus 3 square root 5 over 2, then your y2 must correspond to the plus. So you must have 1 plus 5 square root 5 over 2, which is the golden ratio. And then conversely, your x3, which is 5 minus 3 square root 5 over 2, and so your y3 is 1 minus square root 5 over 2. So how can I actually think about this? Is because I have purposely used the entire sign. I try to look at the signs here, whether or not they are able to, my apologies. So it should be minus plus here because of the minus sign here. So minus plus. So they must be minus plus. So minus plus. So that means if initially your x2, 3 is plus minus, and so your y must be minus plus. Okay, so this is the way to interpret this expression. So yeah, so why I get minus plus? Because of this minus sign in that expression. Okay, unless you have a plus sign, then you have plus plus on the y2 x2 y2 and minus minus for x3 y3. You can actually just check. Okay, just use back the equation. So yeah, if you want to use a calculator, yeah, you will get the y2, which is 1 minus square root 5 over 2. Or you can just use this method to get back the y2 equals to 1 minus square root 5 over 2. So yeah, I recall back what we had done. First and foremost, we obtain these two equations, 1, 2, and then we express them. Well, we gain the expression of x, y in terms of x and also in terms of y. We equate the expressions and then we will get the symmetrical equations, okay, involving the x cubed, y cubed, and also the y and x. So we try to get this in the end, these two things. So we have the fraction here. Notice that the fraction, and we remember that the fact that it's a mathematical competition, so we must have the real solutions. So we try to factor out that, we try to gain the factors of x and y, and then knowing that because this is a mathematical competition, we just use the minimum principle to choose the factors of y, like 1, and then for x is 1. We test out with the least amount of the factor, and then we obtain the fact that x equals to y equals to 1, okay, in the end. And then after many kind of these logical assumptions like 9y squared greater than x squared, and then we can try to conclude that x equals to y equals to 1 must be all the times to gain the real numbers, okay? And then we will have, in this case, the linear factors, which you can obtain all of them from the 9y squared minus x squared, and then you try to break it down using the difference of square identity. So you will have 3y minus x. If you substitute x equals to y equals to 1, you will have 2, and then 3y plus x, you will have 4. And you try to construct these two as a linear equations, assuming that x and y are actually not just equal to 1. Okay, they can be any number. So then we will get the rest of the solution, the rest pairs of the solution. So since we have one pair, so we must get two pairs. And hence, using the trial and elimination method, we will have obtained that x2 equals to this, the plus expression, and then y2 equals to the minus golden ratio, and then x3 equals to the minus expression, and then y3 equals to the plus original golden ratio. Yeah, interesting question. It's just different manipulation ways. So hopefully you might have learned this technique, and thank you for watching this video.